Welcome students to this another class of organic chemistry. So last time we discussed something like we discussed till the resonance structures. So today we'll go ahead and we'll take the further topic, that is resonance effect. So we'll try to discuss it. Okay. Resonance effect. So first of all, we have to know what is resonance effect. So the general definition is the polarity produced by produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair. And a lone pair. Okay, we'll see it with the help of an example also that we'll see later. But first of all, what is resonance effect? It is the polarity produced by the interaction between two pi bonds or one pi bond and one pair of lone pair of electrons. Okay, and this effect, and who is producing this effect? Like present on the adjacent atom, and this effect is transmitted through the chain. Throughout the chain it is getting transmitted. Okay, so this effect is also called mesomeric effect, right? Mesomeric effect or mesomeric effect. So we can call it with both the names, like first is resonance effect and another name is mesomeric effect. Okay, so there are two kinds of resonance effects. One is plus R effect and another is minus R effect. So we'll see both the effects one by one. Okay, first of all, this is first example is positive resonance effect. Positive resonance effect. We call it with another name, that is plus R. Okay, plus R effect. So what is this plus R effect? We will see with the help of an example. This suppose, so the main difference between plus R and minus R is that the transfer of electrons is away from an atom or substituent group, away from the atom or the substituent group. The transference or the transfer of electrons is away 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 from an atom or substituent group attached to the conjugated system. So this kind of effect makes like some of the positions with high electron densities. So we will understand it with one example also, but first of all we have to like understand it theoretically only, and then practically we'll see it with the help of one example. So what is plus R effect? It's the transfer of electrons, or the transfer of electrons is away from, it is away from an atom or substituent group attached to the conjugate system. So we'll see with the help of aniline. Okay, the example, this aniline, with the help of aniline. So aniline is this. Okay, this is aniline, NH2. So here the substituent group attached to the ring is NH2. So then it becomes aniline. So resonance effect is the interaction between two pi bonds, or the interaction between one pi bond and one pair of lone pair of electrons. So in this case, this NH2 is having one pair of electrons, lone pair of electrons. So what happened? Now the substituent group is giving its electrons like away from the, like we have seen, the transfer of electrons is away from the atom. So NH2 is having the lone pair of electrons, and now the electrons will go away from the NH2, and then we will see like this lone pair of electrons now have shifted from here to here. Now what happened? Now here it was a single bond. Now the attack has been on the single bond. Now what happened? Here the electron density increased, and the electron density increased, and it became unstable. And to get stabilized, it in return it donate its electrons also, and it happens like this. The bond from here, this double bond broke. This double bond broke, and the electrons shift from here to here. Okay, so now what happened? This NH2, it has given its lone pair of electrons to this single bond. Now single bond, and then the resonance effect is getting transmitted throughout the ring. So this single bond is donating the electrons to the double bond. Already double bond is there. To get stable, the double bond broke, and the electron gets shifted to the, like, further and further. So this shifting is called, shifting is done throughout the chain, and this is called resonance effect. Okay, so now this double bond got broken up. Now what happened? We'll see in another resonance structure that what happened. This is a resonance. So now what happened? We'll see here. The lone pairs, earlier there was a single bond here, and NH2 was attached, but now NH2 has donated its lone pair of electrons to a single bond. Now on NH2 there is plus sign. Plus means now it has donated. Okay, so now uh, it is not having that lone pair of electrons. Now it is free of lone pair of electrons. Now plus sign is there, but now in the meanwhile the donation has been given to the single bond. Now this single bond has become double bond. This, yeah, see the change. And now the electron, the lone pair of electrons from NH2 has shifted to this position, this then negative sign we will show. So the negative sign means the electron density here is increased, it is more electron denser. Okay, so electron density has increased. So now the double bond has broken. So now we can see the double bond. We will not put double bond here because it has been broken, and the lone pair of electrons has shifted to this position. And yeah, and rest is same. Okay, but now the shifting is going on. Now this lone pair of electrons will shift further. Then we'll see. Now another diagram we'll see. So I am drawing it below. This is the continuation. Okay, continuation of this thing. Continuation. I am drawing it below. So don't think it is it's not separate, it's the continuation. Okay, so now the electrons, they will shift further. How? We'll see. So this much we already know, NH2 plus, how it happened. And now we can see the double bond has broken, the electrons got shifted to this position. Now this double bond from here, earlier it was here, now it has shifted from here to here. Okay, here. And this electron density, the lone pair of electrons has shifted here. So this shifting is continuous process. That's why it is a continuation is going on. So the electrons are here. Now the double bond earlier was here, now it is here. So this lone pair of electrons now attack here. Okay, it was there, rest is same. So now it attacked here. So again this double bond, again it broke down and it has shifted here. Okay, so what happened? Now the electrons got shifted here. That we'll see with the help of a resonance diagram again. This now this double bond has shifted here, and now electrons, lone pair of electrons are there, and now this rest is same. So this is called plus R resonance effect. Plus R means the electrons are shifting away from the substituent group, that we have seen the NH2. In the case of aniline, NH2 is a substituent group and the electrons were there, lone pair of electrons were there, and they shifted away from the substituent group, and then it encircled the whole this benzene ring. And we saw that earlier the double bonds and single bonds, alternative double and single bonds were there. Earlier where it was the single bond, now it is a double bond, and earlier where it was the double bond, now it's a single bond. So we can very easily we can see that. See the first diagram and the last diagram. Clearly we can see that the shifting of the double and single bonds, due to this lone pair is getting shifted, and to get stabilized, this new resonance structure has been formed. Okay, so this is plus R. So we have seen this effect. Plus R effect. Now we'll similarly go towards the minus R effect is there. So minus R we already minus know. R effect. This minus R effect means now towards the substituent group. Earlier it was away from the substituent group. Okay, so minus R effect we'll see, minus R effect, or it is called negative resonance effect also. Okay, so we'll take this example. Okay, so we'll see the transfer of electrons now is towards the atom now. Towards the atom or the substituent group which is attached to the conjugated system. We'll see later what is conjugated system. Attached to the conjugated system. We'll see it what is conjugated system, but after some time. So now the transfer of electrons is towards the atom or the substituent group, that we'll understand with the help of one example. We are having this nitrobenzene. We'll see the shifting. This nitrobenzene is there. So see, this benzene ring is there, and now NO2 is getting attached. So this NO2 means nitro, and benzene, nitrobenzene. Okay. So this one is attached to the double bond O, and another is single bond O. Now what happened? From here, from this double bond, the electrons start shifting towards the substituent group or the atom, like this. So this double bond attacked this single bond. The shifting of electrons from the double bond towards the single bond, and now we'll see in the second diagram what happened. See, now this single bond now has become double bond. Like, remember, we have done already in the plus R effect also the shifting of bonds. Okay, earlier it was a double bond, now it has become single bond, and the single bond has become the double bond. So NO2 is there. So now the shifting took place, and this single bond become the double bond, and here the plus charge is there because now there is deficiency of electrons. So plus charge is there. So it is electron density is getting decreased. Earlier it was increasing in the plus R effect, okay, in the benzene ring, but now it is getting decreased. So the plus charge is there. So but here see, where this double bond got broken up, this the bond between nitrogen and oxygen in the case of nitro group. So now these lone pair of electrons means negative. So this double bond got shifted from here to here, like it has donated its electrons to oxygen. Okay, so here rest is same. But now what happened? Here the deficiency is found. So now this double bond would broke up, and it will be shift here. It will be shifted to this position. Okay, that we'll see in the next diagram. This is the continuation. So now the same double bond oxygen, and 1 2 3 4 5 6 and negative charge on the oxygen. Okay, so now what happened? This double bond in the last resonance structure, it has shifted. So now it has been shifted, and now it has come here. Okay, and now this plus charge again, it has been shifted to from this position to not here, but this plus charge is now here, and earlier it was, the rest is same. Now this double bond will broke up, and it will attack this single bond. Okay, so now what would happen in the next structure, we will see. Okay, so now here, and now this bond has shifted from the last resonating structure's position to this structure, this bond, and now plus has shifted from here to here, like here. Okay, and this double bond has shifted to the Earlier single bond, now it has become double. Okay, the rest is same. Okay, so we have seen the positive charge shifting. Okay, this is minus R effect. Now the electron density has decreased on the benzene ring. Earlier in the plus R effect it was increasing. The density was increasing, and in the plus R effect it was away from the substituent group, and in the minus R effect it is towards the substituent group. So in this manner we have recognized some substituent groups. They show plus R effects and minus R effects. So we will see some examples here. So the substituent groups which shows plus R effect are, they are generally halogens: chlorine, fluorine, bromine, iodine. They are halogens or alcohols, and so on, like many groups, etc. We will not go very deep into this. We will see just the some of the substituent groups. Now who shows minus R effect? Some are carboxylic acid, aldehydes, and carbon oxygen bond, and etc. Okay, now the question that had come before, what is a conjugated system? It's important to know what is a conjugated system. What is conjugated system? It is nothing but the alternate single and double bond, that is conjugated system. The presence of alternate single and double bond. Presence of alternate single and double bonds. Okay, this is called, in an open or cyclic system, in an open chain or in a cyclic system, when the presence of alternate single and double bond is there, this is called conjugated system. Okay, so we have done this resonance effect also, and in the resonance effect there are two types of effects. First is plus R effect and the second is minus R effect. Okay, we have seen both the effects. Now we will move further and we will see what is electromeric effect. And remember, this resonance effect is also called mesomeric effect. So now we are heading towards the electromeric effect. Very important, electromeric effect. It is also called E effect or E effect. Okay, so first of all, this is a temporary effect. Just concentrate on the points that I am telling you. This is a temporary effect, and it is shown by the compounds who is having the multiple bonds, like double, triple bonds, and when they are attacked by a reacting reagent or a attacking reagent, and it is shown by the compounds who is having multiple bonds. Multiple bonds in the presence of attacking reagents only. Attacking reagent only. Okay, so we have seen some of the points of the electromagnetic effect, that it is a temporary effect and it is shown in the multiple bonds. It is shown by the compounds who is having multiple bonds, and when it is getting attacked by the attacking reagent only. Okay, so now we will see the general definition. It is the complete transfer of, it is the complete transfer of a shared pair of multiple bond, shared pair of multiple bond on the demand of an attacking reagent. So we can see it is a complete transfer of a shared pair of multiple bond on the attacking, on the demand of an attacking reagent. Okay, we will see it with the help of an example. So the shifting of electrons takes place. It is also called, it is represented by capital E. And the shifting of the electrons, like when the electrons get shifted, it is, we can show with the help of a curved arrow. Okay, we'll see it with the help of an example. There are actually there are two distinct types of electromagnetic effects. Okay, earlier the resonance effect was of two types. First is plus R and the second is minus R effect. Now the electromagnetic effect is also of two types, that is positive electromagnetic effect and the negative electromagnetic effect. So we will see it with the help of an example each. So first of all, the positive electromagnetic effect. The positive electromagnetic effect. Okay, so what is the difference between the positive E and the negative E effect? It is plus E. So in this effect, the pi electrons of multiple bonds, the pi electrons of multiple bonds are transferred to that atom, are transferred to that atom which atom, to which the reagent gets attached. We will see it, to which the reagent, gets attached. Okay, so with the help of an example we will see it, but first of all try to understand it. The pi electrons of multiple bonds are transferred to that atom which the reagent gets attached. So the example will clarify it further. So suppose we are having this thing, okay, double bond C, and now the attacking reagent is H plus. This is the attacking reagent. Now what happened? This double bond broke up. Okay, and this double bonds electrons got shifted to this C. Okay, this carbon atom. So now if this attacking reagent, this H plus, is going to attach to this C where the electrons has been shifted, is then this effect is called plus C effect. Suppose now the product has become like this. Now this positive charge because electron density is less here, and now C single bond C and this, and now this H plus electron, this H plus attacking reagent has been attached to this carbon atom, and the electrons from the double bond has also shifted from the double bond to this carbon atom, like here. Now this H is attached to this carbon atom, then this kind of effect is called plus E effect, plus electromeric or positive electromeric effect. Okay, so we have seen this. It's very simple. The electrons got shifted from the double bond to the carbon atom where the attacking reagent has been attached. Okay, so now the minus E effect is very simple. Now the electrons are getting shifted to the carbon atom, but the attacking reagent is not getting not getting attached to that carbon atom. We'll see. Now, what is negative electromagnetic effect? Negative electromagnetic effect, or minus C. Minus C. Okay. So now the pi electrons of the multiple bond are transferred to that atom which the attacking reagent does not get attached. Okay. So where the attacking reagent to that carbon, where the attacking reagent does not get attached. Again, with the help of example, we'll see it. Same example. This double bond broke up, and now the same carbon atom is getting the electrons. Now earlier it was H plus, which was the attacking reagent. Now it is cyanide. Okay, this is the attacking reagent. Okay, this is the attacking reagent. Now the final product would be, now this CN will not get attached to this carbon atom which is getting the electrons, but it is getting attached to the other carbon atom. Okay, like this. Like this here. Okay, here. So now the shifting has been done to the other carbon atom, but the reacting reagent, it gets attached to the other carbon atom. So when such kind of things happen, then it is called minus E effect, negative electromagnetic effect. Okay, so now we will move further. So we have discussed this plus R effect, minus R effect, this resonance effect, then this electromagnetic effect, positive electromagnetic effect, and negative electromagnetic effect. So we will move further and we will take up a very important topic, that is hyperconjugation. What is hyperconjugation? We will see it. So what is hyperconjugation? So first of all, what is hyperconjugation? We'll try to understand it. So hyperconjugation is nothing but it is general stabilizing reaction, okay, or interaction. It is general stabilizing interaction, which is try to stabilize the compound. General stabilizing interaction. And what does it involve? It involves the delocalization. It involves the delocalization of sigma electrons means single bond. Delocalization of sigma electrons. Sigma electrons of carbon and hydrogen bond. Sigma electrons of carbon and hydrogen bond of an alkyl group. Which is directly attached to an atom of unsaturated system. Carbon hydrogen bond of an alkyl group directly attached to the an atom with an unshared p orbital. Okay, so we'll try to understand it. Okay, so what is hyperconjugation? Generally it is a stabilizing interaction. Okay, and what does it involve? So this hyperconjugation is general stabilizing interaction. Okay, and we have seen this, it involves the delocalization of sigma electrons of which carbon hydrogen bond of an alkyl group, which is directly attached to an atom with an unshared p orbitals. Okay, it's little complicating, so we'll try to simplify it. How? With an example. So to understand the hyperconjugation effect, let us take the example of ethyl cation. So example, we are taking this ethyl cation. Okay. So this is ethyl and this is cation due to the presence of this positive charge. Okay. So now here this carbon atom, which is positively charged, this CH2 carbon atom, here it has an empty p orbital. Okay, so this carbon, it is having this positively charged atom, this positively charged carbon atom. Okay, that's why it is cation, positively charged cation atom has an empty p orbital. Okay, so now the electrons in this carbon and hydrogen bond, like it is, they are getting delocalized into the empty p orbital. How? We'll see. So I'll draw the structure and then we'll try to understand. Okay, so this is carbon and hydrogen. Now this hydrogen, and this is the carbocation, this carbon. Now H. Now this one H, and it has empty p orbital. Okay. Okay. So now the hyperconjugation, the delocalization of electrons between this carbon and hydrogen, here it happens like this. here. So now here the hyperconjugation happens. Okay, and now it is having, why it happened? Because it is having empty 2p orbital, and this is of carbon. Okay, this is of carbon. So this is the orbital diagram showing hyperconjugation of ethyl cation. So to clarify it more further, what we have done, like we have taken the example of this ethyl cation, and this in this ethyl cation, this positively charged carbon atom is having empty p orbitals. So now the electrons constituting the carbon hydrogen bond in plane with this p orbital, that can then be delocalized into, it got delocalized into this empty 2p orbital, okay, as we have shown in this figure here. Okay, so like why this type of overlap happens? Generally to stabilize the carbocation. This carbocation is now unstable. So to stabilize this carbocation, such kind of delocalization happens. Why? So the reason is that why this delocalization happened, because this type of overlap stabilizes, because we have already discussed this is a general stabilizing interaction. So this type of overlap stabilizes the carbocation. Because why it is stabilizing the carbocation? Because electron density from the adjacent sigma bond helps in dispersing the positive charge, So with one example we can see this. See, carbon carbon single bond, then this one. Now this is the carbocation. This carbon atom is having the positive charge, so it is the carbocation. Now the delocalization will happen. How? This, now the double bond. So earlier 3 hydrogen atoms were there, but now this hydrogen atom has been shifted from here to here, and now that's why it's a double bond between carbon atoms. So now it has become H plus, because it has donated its electrons. Now it has become H plus, and the same thing. Okay. So again this H plus, we'll take it separately. Now carbon carbon double bond, and now it has come out and we have written it here. Okay, so now simple C double bond C and 2 hydrogen atoms attached to the carbon. Again, so we can write it like this also, the same thing. Now this hydrogen atom has gone here, like it is getting shifting. Earlier it was here, then here, then here. Okay, so now this position, then this position, and now this position. Okay, this position, this position, and this position. Now it is getting shifted. So we have seen that this delocalization is happening to stabilize the carbocation. Okay, so I hope it is clear to you, this hyperconjugation. Now we will move further. So generally, greater the number of alkyl groups attached to the positively charged atoms, carbon atoms, the greater the hyperconjugation, right? Greater the number of alkyl groups attached to a positively charged carbon atom and greater the hyperconjugation. Greater the hyperconjugation. So it's very easy. The greater the number of alkyl groups attached to a positively charged carbon atom, greater the hyperconjugation. Okay, so we have the following relative stability of carbocations, like this. This is a carbocation and 3 alkyl groups are attached. So it is more stable than two alkyl groups attached to the carbocation. It is more stable than the single alkyl group attached. Okay, and it is more stable than no alkyl group is attached. Okay, so we have seen this stability of carbocations, like more the alkyl groups attached to the carbocation, more the stability. So now this hyperconjugation is also possible in the alkenes and alkyl arenes. Also possible. So this hyperconjugation is also possible in alkenes and alkyl arenes. Okay, so now you might be familiar with this, the concept of hyperconjugation. So we have seen that what is hyperconjugation and what are different aspects of hyperconjugation. Okay, now we will see some basic concepts, like what are the types of organic reactions and their mechanisms. But right now we will not go very deep into this, but a general overview we will take. So types of organic reactions. Types of organic reactions. So first kind of organic reaction is substitution. Substitution. So this substitution is nothing but when one group is getting substituted by the another group. So right now we will not see the examples and other things, but a general overview and a general introduction to this concept. Okay. So this substitution reaction is nothing but the substituting of one group with another group. Okay. So now the second is addition reaction. When we are adding something and it is getting attached, then it is called addition reaction. Okay, addition reaction. And the third one is elimination reaction. As the name is suggesting, elimination means it will eliminate something as a separate product and some other group will attach there. Okay, but the main purpose of the reaction is to eliminate something. So that's why it is called elimination reaction. Then the fourth one is rearrangement reaction. As the name is suggesting, the rearrangement means the groups or atoms will rearrange its position. Like in a many other products can be formed with these all kind of four reactions. Okay, so but now we will not see it, we will see it in our further classes. So we have seen this, the whole chapter about the organic chemistry, some basic concepts, and these concepts are very important to further take up the organic chemistry into a deeper level. So now some basic purification methods are there for the organic compounds to get purified, and like some are there. So some concepts are there like methods of purification of organic compounds. Okay, so methods of purification of organic compounds. So these are the methods which are employed to purify the organic compounds, and we will not go into the details. These are very simple. You can learn it and you can understand it on your own also. So like first is sublimation. This is sublimation method, and the second one is crystallization to purify the compounds. Crystallization. And the third one is distillation. And the fourth one is differential extraction. There are the different extraction techniques that you might have studied in your junior classes. Differential extraction. And the fifth one is chromatography, to separate the different components of a mixture. Chromatography. So these are some of the techniques that we employ to purify the organic compounds. Okay, so now we'll stop here and we will meet again for further discussions on other organic chemistry topics. Thank you.